Okay, so for the 7.5, 7.6 group work, we've just got some vocab first. So we have, if you divide the number of elements in a sample with a specific characteristic by the total number of elements in the sample, the dividend is the sample proportion. Okay, so that is the sample proportion dividing the number of elements with that characteristic, so brown eyes, out of the total number of people in the sample. Like our very first example, 8 brown eyes out of 10 people. The symbol for this is p hat. Excuse me. Number 2, the mean of the sampling distribution of the sample proportion is equal to the population. Excuse me, I'm going to sneeze again. Oh, there we go. Okay, mean. And the symbol for this is the mean of p hat. And then number 3, let's see, the standard deviation of the sampling distribution of the sample proportion is C, the square root of PQ over N. So square root of PQ over N, and that is the standard deviation of p hat. All right, number 4, in the case of proportion, if the sample size is large enough, the sampling distribution of the sample proportion is approximately normal if C and P and NQ are both greater than 5. All right, so let's do some problems here. Number 5, a company has 411 employees and 104 are college graduates. The proportion of employees this company who are college graduates rounded to 3 decimal places is what? So that would be 104 divided by 411. So 104 out of 411 gives us 0.2, we're 3 decimal places, 0.253. All right, number 6, 40% of all students in a large university live on campus. Suppose you extract a sample of 115 students from this university. The sample proportion is the proportion of students in the sample who live on campus. All right, so the mean of the sample proportion is what? So this is actually kind of hidden here because it's written in words and not as a number, but it's right here. 40% of students live on campus. So that mean would be 0.40. The standard deviation, okay, for 4 decimal places, you have a sample size of 115. That's your N. Your P is 0.4. And your Q then would be 0.6. So your standard deviation of your proportion is going to be the square root of PQ, so 0.40 times 0.60 over 115. So let's go ahead and do that. 0.4 times 0.6 divided by 115, and then I'm going to take the square root. So 0.0457. All right, so number 7, suppose the proportion of elements in a population that possess a certain characteristic is 0.62. The probability that the sample proportion for a sample of 120 elements drawn from this population is between 0.62 and 0.67 is what? All right, so let's get the information we need. We have the proportion for the characteristic is 0.62. So our P is going to be 0.62, which means our Q is going to be 0.38. 1 minus 0.62. Our sample size is 120 elements. And what we need to do is we need a z-score between 0.62 and 0.67, so for both of those values. So in order to do the z-score, I need a standard deviation of my proportion. So that's going to be the square root of p times q, so 0.62 times 0.38 over the sample size 120. So let's go ahead and do that. So square root of 0.62 times 0.38 divided by 120 gives us 0.0443. 0.0443. Okay, so that's my standard deviation. Then I want a z-score for 0.62 and 0.67. So we'll do that we'll start over here. So I have p hat, so 0.62, minus p, which is also 0.62, over my standard deviation, 0.0443. Well, 0.62 minus 0.62 is 0, so this z-score is going to be 0. My second z-score will be 0.67 as p hat minus 0.62 over 0.0443. Let's see what that brings us. So that's going to be 1.1289. Sorry, 1287. Okay, and then if I draw this, that means what is the area between 0 and 1.1287? So this shaded area right here. So we will go normal CDF, and then a lower limit of 0, an upper limit of 1.1287. So second distribution, normal CDF, 0, 1.1287. I'm going to get 0.3705. Okay, so the probability that I guess this certain characteristic is between 0.62 and 0.67 out of these 120 elements, the probability is 0.3705. All right, and then our last problem, suppose that 6.5%, I should say of, all persons are allergic to peanut butter. A sample of 558 persons is selected. The probability that less than 9% of persons in the sample will be allergic to peanut butter is what? All right, so let's get the information we need. The P is going to be 6.5%, so 0.065, which means 1 minus 0.065 is 0.935, but let me just check that. So 0.935. Our sample size is 558. Okay, and then we need a standard deviation of this sample. So that is going to be the square root, and my computer is not responding. Just give me 1 second. Oh, everything I wrote before that just went away. Okay. Nope, still not responding. Okay, so we want to do, for the standard deviation, 0.065 times 0.935, and then over 558, square root of that. All right, so square root of 0.065 times 0.935 divided by 558. So it's going to give us 0.0104. Okay, and now we want the probability that p hat is less than 9%, so 0.09. So we need to convert that to a z-score. So we will do p hat 0.09 minus our p 0.065. I have no idea where this stuff just went. Over our standard deviation 0.0104. All right, so 0.09 minus 0.065 divided by 0.0104 gives us 2.4038. That is our z-score. Okay, put this on the chart. Here is 2.4038, and we want the probability that less than that, so that's going to be this area to the left here. So when I put this in my calculator, I'm going to have a lower limit of -99 because I'm going to the left. So normal CDF, -99, comma, 2.4038. So that's going to give us 0.9919. Okay, so that means out of this 558, the sample of 558, based on the fact that 6.5% of people in the population are allergic to peanut butter, if I take a sample of 558 people, there's a 99% probability that less than 9% of those people are allergic to peanut butter. So what is 9% of 558? So there's a 99% probability that less than 50 people in that sample are allergic to peanut butter, based off the fact that only 6.5% of the population are.